Hello and welcome to this IB Maths Intense session, part of our topic 3, geometry and trigonometry, working with triangles. This time we're looking at how to find the area of a triangle using trigonometry, specifically the sine ratio. This is on the syllabus as part of SL 3.2. You can see there it refers to finding the area of a triangle. It also says in SL 3.2 that this section doesn't include the ambiguous case of the sine rule. Well, we're going to look at that a little bit in this particular video, and we'll look at it later. But this is part of SL 3.2 and a little bit of SL 3.5. So, without further ado, we know from the maths we did earlier in our schooling how to find the area of a triangle. And in the three examples here, we've got three triangles where we've got the base and the height of the triangle. And in those cases of the base and the height, we're able to just use the simple formula that the area of a triangle is half of the base times the height. Nice and straightforward. But we need to look at what happens in the circumstance where we don't have all that information. Imagine we've got this particular instance. I've got one of the angles and I've got two of the sides. Now in this particular circumstance, this is called having the included angle. I've got two sides and the included angle. Now the included angle, as the name suggests, means the angle that is included or contained by the two sides. So in that case there, the angle is 52 degrees, and on either side of the angle are the two sides, 6 and 10. Now in this case, I can also find the area of the triangle, but I'm going to use some trigonometry to do so. So this video is all about this scenario, two sides and an included angle, and then being able to find the area. Now, before we go further ado with using the formula, let's just make sure we know what the general standard is for labelling triangles. In general, we'll label the three vertices of a triangle as A, B and C, and we'll use capital letters to denote the vertex and the angle inside it. So effectively, this angle here is A degrees, this one is B degrees, and this is C. And we're using capitals. And then we denote the opposite side with lowercase a, lowercase b, and lowercase c, because the angle and its opposite side are related to each other. Those are the ones that share a special relationship in terms of their ratios. So we'll always label a triangle in that way. So for a vertex, the angle is a capital letter A, and the opposite side to that is labelled in lowercase. Now, of course, I didn't have to label that as the top one as A. I could have used any of the three as A, but then the opposite side to it would have had to be A. Okay, so make sure you always label your triangle, because then it's very clear which side is which in reference to its opposite angle. So here we go. Here is a triangle, and I've labelled the three vertices A, B and C, and I've labelled the three sides correctly as lowercase a, b and c, so I know which are which pairs. And what I'm going to do here is just going to go back to some basics and see if I can find the area of this triangle. Now, what I really need is this perpendicular height, but I haven't got that information. But what I do know is, now that I've dropped that perpendicular height, I've created a right angle triangle here with sides with the hypotenuse of b. So I can use the sine ratio to tell me that sine c, the angle down here in the corner, is, well, sine is opposite. Well, its opposite is equal to h, the height, divided by the hypotenuse, which is b. So if I rearrange that, the height of this triangle is actually b times sine c. And now I've got enough information to use half base times height to get the area. Area is half of the base, well, the base is a, and the height is b sine c. So the area of a triangle is equal, and the bits that I need to know that I used in that formula, I needed to know about this angle here, I needed to know about the length of b, and I needed to know about the length A. And there we have it. So area equals half AB sine C. Now, I could have equally done that using any of the other two angles. So I could have got a similar formula from half BC sine A. So using the angle A over here and its two sides, where A is the included angle for B and C. And that would also have been equal to half AC sine B if I'd have gone with this angle here and these two sides. So I've got three equivalent formulae that give me the area of a triangle. And they are not all on the formula sheet, just one of them. There it is, area of a triangle equals half AB sine C. But don't forget that you can interchange just so long as the angle has the two sides that contain it as part of the formula. So it'll always be the three different letters of the alphabet. Half BC would go with sine A, half AC would go with sine B, and so on. So let's do an example. In this triangle, I'm going to label the sides. This one's side B, this one's side A, and this one's side C. So I've got sides A and B, and I've got the angle C. So the area of this triangle will be the half times 10 times 12 times sine 32. Notice how it's the two sides that include the angle. And then just working that out, 10 times 12, 60 sine 32 will give me an answer on my calculator of 31.8 centimetres squared. Very simple. The only complexity, if there is any complexity, is really just making sure you've got the right sides and angle to put into the formula. In the next example, just to show you, this time if I label my sides now, I've got the side C and I've got the side A and I've got the angle B. So I would want to use area equals a half AC sine B this time. It's the included angle. Sine B is the included angle for the two sides A and C. So here, area will just be a half times 8 times 14 times sine 58. And if I work that through on my calculator, I find that's equal to 47.5 centimetres squared. Something like that. Okay. Not every question will be absolutely as straightforward as that. We might have to work backwards from a given area. So in this particular question, again, I'm just going to check the sides. I've got side C there, this is side B, this is side A. So I have got an area of 100, and that was equal to a half BC sine A. So a half x times 14 sine 94. So x, my missing side, half times 14 is 7, 7 sine 94. X equals 100 over 7 sine 94. And that gives me an answer on my calculator of 14.32. So you might be asked to work backwards, not to find the area, but be given the area and then find a missing side. And that's fine, just one solution. Now, the only slightly tricky point is the ambiguous case that was referred to in the specification that I mentioned at the beginning. There are some problems that have two possible solutions, and that's where we're working backwards to find the included angle. And that's because on our remember our ASTC picture, our all students take CAS picture, we knew that the sine ratio is positive in both these two quadrants, angles between 0 and 90 degrees and angles of between 90 and 180 degrees. So in some cases, when we're working backwards to find an angle, there may be more than one solution. So let's have a look at this. We know that we've got an area of 30, and it was equal to a half times 8 times 10. The triangle has got sides of length 8 and 10, and its included angle we're trying to find. So half AB sine C, for example, let's call the included angle we're trying to find sine C. And it gave an area of 30. So sine C was equal to 30 over half times 8 times 10. Half of 80 is 40. So sine C was equal to 30 over 40, which is 3/4. So on my calculator, the principal value that's going to come back is that C is equal to 48.6 degrees. And that would make sense. I could have a triangle that's got a side of 8, a side of 10, and the included angle there would be 48.6 degrees. These are centimetres, and there we go. That would work. But I also know that if in my all stations or my all students take CAS thing that we talked about before, if I've got an angle of 48.6 giving me a sine ratio of 3/4, I could also get a sine ratio of 3/4 in this quadrant based on the angle of 48.6. So we would have a second angle that C could also equal 180 minus 48.6, which is equal to 131.4 degrees. Because there are two possible solutions between 0 and 180 where sine C equals 3/4. Look back at the work that we did on the unit circle if this isn't clear to you, if you've just jumped in on this video. But there are two solutions. And that would give us a triangle with a side of 8. This time at an angle greater than 90 degrees, 131.4, and a side of 10 there. Like that. And the angle here would be 131.4. So there are two possible triangles that meet the information that we've given. They've both got an area of 30 centimetres squared, and they have sides of length 8 and 10. So there's an ambiguous case when you're working backwards to find the angle. Okay? Watch out for that. So that's pretty well it in terms of finding an angle, finding the area of a triangle using half AB sine C. Thank you for watching. I hope you found that useful. Don't forget to like this video, subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. Drop me a line on ibmathintense@gmail.com. Give me any suggestions, things you'd like to hear, mistakes that you might have spotted. But in the meantime, stay healthy and enjoy your maths.